payoff and resulting outcomes might not be the same as expected or planned. Is it true? There is more of that. Okay. We'll skip this. You can read it later.
Could you please explain the first one? Why?
The more number of decisions in a tree, stop my decision below, accurate one. That is the main reason. There will be some grey area. Say for example, I mean, restaurant is very clear. Veg, non-veg, even though non-veg, now there is a question of fish, mutton, chicken. Now you don't know, suppose for you, suppose all the three are equally important. Now how do I start? Then you get stuck. Because in reality, suppose you prefer fish a little more than the other two. But based on sheer data, I mean, the chicken type is you which you prefer. So that is one of the reasons why it says sometimes for a big tree, the accuracy could be good. Applications. Now, remote sensing is an application area for pattern recognition based on decision tree. Finance option pricing. Banks to classify loan applicant by their probability of default. This is a really practical example. Huge amount of data analyzed for it. What they try to do is they try to find out that whether a new applicant will default or not. And defaulter, it also wanted to say credit do. I mean, credit do. So that is what it means. Biomedical engineering uses of decision tree for identifying features to be used in implantable devices. Implantable devices, suppose, say, I mean, at a pacemaker was it. So, what will be the effect? Knowing my certain characteristics.
So what is remote sensing?
Remote sensing area for identifying based on remote sensing area, IRS. IRS. But remote sensing is satellite. You can try to sense remotely something. Remote sensing can be very simple also. Say you planted a monitor in your house and you are trying to monitor it from here, which is maybe 10 kilometers from your house. That is remote sensing. So molecular biology initiatives such as Human Genome Project and GenLand database, fascinating opportunity for machine learning and other data exploration method in molecular biology. Recent use of decision tree for analyzing amino acid sequence can be found. Now, incidentally, Human Genome Project or GenLand, Human Genome Project, is a fascinating story by itself, having to do with ML. You can try to find out where we have done, what we have done, and what we have not done, and where computers, in fact, last 5-10 years, what has happened in this genetics engineering is, earlier, only biologists or molecular scientists used to try to solve the problem. In the last 5, 6, 7 years, now these computer guys have also mixed up with them, and they are writing huge set of algorithms to help analyzing the genome data. Now that has really exponentially increased the type of things that one can infer from Human Genome Project. Random forest is another application name. Now let's continue with the same example that we used in decision tree to explain how random forest works. Your friend is a decision tree, however, being a human being does not always generalize your restaurant. So to get more accurate restaurant recommendation, you ask a couple of your friends and decide to visit. মানে এটা কি হলো আমার চারটে বন্ধু আছে আমি প্রথমে বললাম যে আগেরটা ডিসিশন ট্রি আমি শুধু ওভার আর সঙ্গে কথা বলছি random মানে I am now trying to get input of all these 5 or 6 people and then try. So that means each will have a decision tree. Now you take the average result of this and that is called random forest. So to get more accurate recommendation, you ask her, instead of just asking one friend, you would like to ask others who vote on whether you will like a particular restaurant or not. This implies you have built an ensemble classifier of decision tree. অনেকগুলো decision tree I'm going to collect করে I'm trying to get a result. So that is what random forest basically now but that is what it does. Is the same thing I have just written in the case of slightly altering your restaurant preference, you are injecting randomness at model level. So your group of friends now form a random forest of your restaurant preference. A model is trained several times on random sample of the dataset to achieve good prediction. In this ensemble, the output of all decision trees in the ramp is combined to make a final prediction. The final prediction derived by polling the results. So that means, for instance, in the above example, if 5 friends decide you will like R, but 2 friends decide you will not like, the final prediction in that case will be R at, because you are taking here the measuring part. Okay, so why use? You can use it in Python, accuracy, simple to use as basic, is implemented with a few lines of code that will show. Advantages: overfitting is less of an issue. We'll see why. These algorithms are fast, but not in all cases. If the number of random forests becomes more, then it becomes a big issue. It is one of the widely used variety of classification and regression tasks. In fact, random forests and SVM, these are the 2 most common algorithms that you see when you subscribe to some blog. These are the 2 very actively pursued I have seen at least. It can be grown in parallel, obviously, because parallel কেন না আমি অনেকগুলো মেশিনকে ভাগ করে দিতে পারি, A3, 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 A3 and so on. It can also run efficiently on large database. There are some drawbacks also, you can go through them. I'm not reading it out. Applications, again, bent to predict loan applicant. They are also used in automobile industry to predict the failure or breakdown of a particular mechanical part. Healthcare industry to predict if a patient is likely to develop a chronic disease or not. Now, these are really very wide because a lot of decisions are taking place. Or বয়স কত, কি ওষুধ খায়, স্মোক করে কিনা, কোন শহরে থাকে. So all those decisions combined together can be brought together to come to this. Logistic regression machine learning is a confusing in the sense that logistic regression is for classification task and not regression. The name regression here implies that a linear model is fit into the feature space. So logistic regression applies to a logistic function to a linear combination of features to predict outcome of a categorical dependent variable. Suppose you want to predict if there will be a snowfall tomorrow in Shimla. Here the outcome of the prediction is not a continuous number because there will either be a snowfall or a no. So it is almost a yes-no kind of a scenario. কাল বৃষ্টি হবে কিনা? এই টিউমারটা malignant or benign. So there logistic regression is used. There are some subcategory, I'm skipping it, but it is there. Advantages: it is more robust. It does not assume linear relationship. It may handle non-linear effect, but it requires much more data to achieve a stable and meaningful data. আমরা এটা পরে দেখব কেন ডেটার সঙ্গে কি রিলেশন. Common applications: image segmentation and categorization, handwriting recognition, healthcare, prediction whether a person is depressed or not based on a bad words the corpus seems to be conveniently serving using. এইটা কি করে করা বলতো? আমি ধরো ফেসবুকে পোস্ট করে যাচ্ছি, ওকে, আজকে 10টা, কালকে 5টা. Now one can actually read and analyze these posts to find out what mental state I am, whether I am jovial, whether I am depressed, whether I am not well, maybe sick. So that sort of categorization and prediction also can be done using this. Marketing, say response or no response, or credit card loans, and so on. So you can see one thing, that credit card loan example has been mentioned at least 3-4 algorithms. So there is no one, the reverse is also true. So for credit card case, fraud or loan defaulter case, there is not one single algorithm where you can use. You can use multiple types to get which particular give you the best result. Okay, we will skip this. There is a reason behind it. You can, I will give these slides to you so you can KNN, K nearest neighbor. This is both used for classification and exam. Mostly used for classification. Nearest neighbor, content retrieval, and biggest use of KNN search is recommender system. KNN is used heavily in recommender system. You know? Very simple example, recommender system and model. Suppose you want to buy a particular brand of camera. Now, recommender system, what we try to give is trying to find out all the feature of that camera and what is next close, maybe 1 or 2 to that camera. So they will also show not just from the price point of view, but also from the feature point of view. So camera may have a DSLR, it can have say 20 megapixel, it can have a zoom, it can have maybe an aperture and so on. So all those parameters which will be something close to another or another. So that is what the recommender. So this is where the KNN nearest neighbor algorithm does. This we will skip. KNN is a very new, very new buzz thing, but it is basically based on, as Sarah said, artificial neural network is based on human brain, the way it is acting. They are trying to mimicry through computer. Okay. Try something else. Learn to one time.
Repeat them. Repeat it.
Sir. There are 2 books which write the KNN algorithm. You can use this scikit-learn where KNN is already there, so you don't have to write the Python logic. Introduction to scikit. So it is released in 2007, so it is relatively new. One of the most popular open source machine library for learning library for Python. It provides algorithms for machine learning, including classification, regression, dimensionality reduction, clustering, and so on. It provides modules for extracting features, processing data, and evaluating models. Conceived as an extension of SciPy and NumPy, matplotlib. So যদি if you want to install one thing, if you in your machine, if you want to install any library which is not there by default, the command to do is very simple. You have to just say pip install and then the library name. Say library name you want to install scikit, so you can just say scikit-learn. Of course, an active internet connection has to be there. Then it will install, including all its dependencies. So, if you do the NumPy install kota hai alada kore hate, then you just say pip install NumPy. That's all. Yes. So just to install any external library, you have to do this. So, scikit-learn provides a range of supervised and unsupervised learning algorithms via a consistent interface in Python. It is licensed under BSD and it is distributed free, encouraging both academic and commercial use. So, you can understand that anybody and everybody can use it free. It is there and it is actively being pursued. So, some of this stack which you should be aware of using any meaningful ML, that your library set should be this all NumPy, SciPy, Matplotlib, SymPy and Pandas. It will be easier for you. Some of the popular group of models provided by scikit-learn include clustering, যেমন তার k-means হচ্ছে one of the, cross validation, data set, dimensional deduction, ensemble method and feature extraction. All these broad categories each have a number of libraries, number of functions. আমি এগুলো ইচ্ছে করে স্কিপ করছি কারণ আমি এবারে দেখা যাক সত্যি যে কাজটা অ্যাকচুয়ালি করে। Now, scikit includes a few well-known data sets. মানে ওর লাইব্রেরিটার মধ্যে কয়েকটা sample data set already is there. Here we will use a famous ID's flower data set. Now, ID's flower data set is one of the most commonly used data set while learning ML. It is সবার প্রথম data set হয়। It comprises, it basically includes information about 150 elements, মানে 150 টা row আছে, instances for 3 different type of flower, ID's flower, and its sepal and petal length and width. অর্থাৎ just বোঝানোর জন্য sepal width, length, petal width, length, এবার কি টাইপের ফ্লাওয়ার সেটা থাকে হচ্ছে 0, 1 আর 2, এই রকম রেকর্ড 150 টা আছে, each of 50 type. Now this is a given data set. So এখানে একটা জিনিস just I wanted to highlight. The natural task to solve using this data set is to learn to guess the ID species knowing the sepal and petal measures. অর্থাৎ আমি যদি এই ডেটা সেটটাকে ইউজ করি and if I learn from this data set, then একটা নতুন স্পিসি যদি আমি দিই তাহলে তার 0, 1 না 2 হবে সেটা আমি কারেক্টলি গেস করতে পারব। This is what we are supposed to do. So that means this is the given data set. We have to train a model based on this data set and then use a new one, not from this set, a new one, and then predict whether this part, so that means this part, this is the target, and these are individually called features, F1, F2, F3, F4, chapter feature, 8 data set. So how can we do this? Let us see. Let's impose the data set and see the values. এটা আমি একদম prompt থেকে করছি কিন্তু you can also do from program. This is a Python prompt. From scikit-learn import dataset. Iris equal to datasets dot load underscore iris. মানে এটা বললে ও iris datasetটা ইয়ে করবে। এবারে x iris and y iris equal to iris data and target. Data কোনটা target কোনটা? এটা data, এটা target. And so the output of আমি যদি বলি shape মানে basically data frame এর একটা shape মানে row by column টা দেয়। So here it clearly says that x part is 150 by 4, which is true, and this is 150 by 0 মানে basically 150 here. So I can also see x iris 0 and y iris 0. তাহলে আমাকে দেখাবে যে এটা হচ্ছে চারটে ভ্যালু আর এই 0 মানে হচ্ছে এটার এই চারটে টাইপটা হচ্ছে ওখানে বলে দেওয়া আছে there are something called setosa, versica এরকম তিনটে মানে নাম আছে বায়োলজিক্যাল নাম of that iris flower. So 0 belongs to setosa, 1 and 2 এরকম. So it is just loading the data column. This data is already there in the scikit-learn. আমি ওটাই নিচে যা বললাম তাই। Now, let us see in detail. কজনের ঘুম পেয়েছে একবার মেরে চলে আসবে চা ব্রেক কখন এবার দেখতে হবে এটা we will go into a very detailed explanation of one of the algorithm, how to use it in Python using scikit-learn. কেন detail? কেন ইয়ে তার কারণ একটা যদি how to use আপনারা বুঝতে পারেন you will be able to use any one of the algorithms similarly. সেখানে আমরা একটু ডিটেইলে যাব বুক পেলে দু পা হেঁটে আসতে পারেন বাইরে। Now our problem is linear classification. We will try to predict the iris flower species using only two attributes, sepal width and sepal length. মানে আমার চারটে ফিচারের বদলে আমি জাস্ট দুটো ফিচার I am choosing. I could have chosen all the four also, but just for simplicity. This is an instance of classification problem where we want to assign a label, a value taken, an item according to its feature. Let's build our training data set and a subset of the original sample represented by two attributes we selected and respective value. After importing the dataset, we will randomly select about 70%, 5% of the instances and reset the remaining ones for evaluation. What we normally do, let us try to find out. Given any data set, say that there is something called training. Any data set is broken down normally into either a 75-25 or sometimes maybe 80-20 ratio. This part is used to train the data. This is the training data. This part is used for testing or testing data. The basic funda again I repeat, you get the whole data set, randomly choose, there is a one step method to do that, you don't have to do it. Randomly choose any 75 part of it and use to train the model. Now once you get the model, you apply this to the model to check whether this portion of values are coming carrying or yes or no. But it is all you know. This is known data. So you train a part, test it. If it is correct, great. If it is not, then something is wrong. So you have to then change the logic or change something. If it is okay and more or less the accuracy or the tally thing is good, maybe accuracy is 90% or 95% or something, then only you go for the unknown data. এই স্টেপটা বলে গেছে জেনারেলি, আমি একবার এগুলো আবার দেখাবো এখানে। তবু get any data, choose 75 or 80% of it as training data, use a model মানে ওই লিনিয়ার ক্লাসিফিকেশন না SVM না ডিসিশন ট্রি না কি, মানে লজিকটা কি ইউজ করব। এবার মডেলটা ইউজ করে we will see, apply the test data to find out what is the accuracy of it, whether the result of my algorithm and result as written here they tally or not. If they tally, great. If they do not, then something is wrong with the model. We have to do something. If it tallies, এটা এখন ফার্স্ট পার্ট হলো। ওই সুপারভাইজের ছবিটা মনে আছে, একটা ফার্স্ট পার্ট আর সেকেন্ড পার্টে। ফার্স্ট পার্টে একটা ট্রেন পার্ট ছিল আর একটা টেস্টিং পার্ট ছিল, another part was the predict part. Predict part কখনই আসবে এই পার্টটা। So that means this part you can say as the first part, and after everything goes right, so this is actually the first part, this is the second part, this is the third part. If only 1 and 2 is successful, then only I will try to predict the result, not otherwise. How can we do this? দেখা যাক। আবার বলছি, যাদের যাদের ঘুম পাচ্ছে একবার হেঁটে আসতে পারে ওই সিএবি মঠে। সবকিছু এই লাইব্রেরিতে দেওয়া আছে। From scikit-learn there is something called cross validation, import, train, test, split. Now there is a function to split the data. So input preprocessing, get the data set with only first two variables, x or y, iris a colon comma colon 2 মানে আমি ফার্স্ট দুটো লিখছি, আর y irisটা পুরোটা, x টা থেকে আমি শুধু দুটো নিলাম। মানেটা কি? এইটা আমার x, এইটা আমার y, y টা পুরো লিখছি কিন্তু x এর শুধু প্রথম দুটো লিখছি। ঠিক আছে, ওই স্টেটমেন্টটার মানে তাই। And then split the data 25% taken randomly. এইখানে আচ্ছা, another feature of Python I ভুলে গেছি বলতে, I can have multiple variable assigned in one statement. এই স্টেটমেন্টের এই দিকটা will give you 4 results which are stored in xtrain, xtest, ytrain, ytest. আর স্প্লিটটা কোনটা না, মাদার ডেটাটা হচ্ছে x আর y, টেস্ট সাইজটা হচ্ছে 0.25, র‍্যান্ডম স্টেটটা হচ্ছে 33 মানে আমি একটা র‍্যান্ডম নাম্বার দিচ্ছি। This can be random, can be 20, 21, 30, 40, whatever. So that means that randomness only. কেন randomness? কেউ বলতে পারে কেন randomness? ওকে, আমি বলি, এই যে ভ্যালুটা 150টা আছে, অরিজিনাল ডেটাটা সাজানো হচ্ছে সবকটা 0, তারপরে 1, তারপরে 2। তো if I take 75 out of this, আমি তাহলে শুধু 0 and 1 গুলো পিক আপ করবো, 2 টা করবো। Sorry, now I'm saying the original data has 150 rows, but arranged in a particular way where all the 50s are first of all 0, then 51, then 52. So if I just split 75-25, all the 0 and 1 will go there, 2 will come here. These are wrong data. So that is why we are picking up randomly. So that is the randomness. So to break the data into test and train, you only require this only one line. This. If I print the shape means you will see that 1122 and 112. So train data has now been, out of 150, only 112 has been chosen with 2 columns, not 4. Okay? Now standardize the feature by pre-processing standard scalar fit xtrain. এটা কিছুই না, this is basically this x data. If you have just a minute, x data হচ্ছে এরকম 5.1, 3.5, 1.4, 0.02. Now if these numerical values are very diverse, then to compute nearness or any comparison will be not proper. So to do that, you do a pre-processing which is called scaling the data, and bringing, basically scaling here what it does, scaling here basically takes the average and subtracts the mean and then write it down. So that means OR then becomes something similar spread. So this is what it done for the train and the test data. Only done for X, not done for Y. Because Y data does not need that. Y data is only 0, 1 and 2, nothing else. This is automatically builds the training and evaluation. Why not just? This is because what I explained. This is what I explained. We always want our training data to be a representative sample of population they represent, not any first data. Randomly it has to be. Feature scaling is what is that? For each feature, calculate the average, subtract the mean value from the feature and divide the result by their standard deviation. So after scaling, each feature will have a 0 average with a standard deviation of 1. This standardization is then used for further processing. Okay, now let us use a PyPlot and Matplot library to help us with this. So this is a code I am not explaining, but if you see, the resulting plot is something like this. So that means for the data that I have selected, red dots are one category, that is 0, versicolor is 1 and Virginica is 0, 1, 2. So as you can see, the sepal length and width, if I plot of the category 3, this is how it looks. Now, just by looking at this, you can see that the red ones are very clear. It is clustered in one area. But the green and the blue one, most of them are clustered together. So, how to fit a line which represent the separation? That is the question. We can see that the separation between the red dots and green and blue is quite clear, while separating green and blue is a difficult task. This is a very common scenario, and one of the first questions we want to answer in a machine learning task is if the feature set we are using is actually useful for the task we are solving. If we do need to add new attributes or change our method, so this is by looking at it. So given the available data, let's for a moment redefine our learning task. Suppose we aim, given an iris flower, to predict if it is a setosa or not. Now that is very simple, right? Whether it is coming towards the red side or not. Because the further classification in the downside is difficult. So that is why it has changed. So now we have converted our problem into a binary classification task. Yes or no? Setosa hobe ki na? And that is, we only have two possible targets. We do look at the picture and do this. Okay. So this is what our first classification, linear classification modules does. So to implement this, we will use something called a stochastic gradient descent. It's a variation of linear classification, very popular numerical procedure to find the local minimum of a function. This is all stat. Forget about it. Let's see how we can use it. So very simple. You just call the algorithm from scikit-learn linear model scikit-learn import SDD classifier. Then CLF, this is a variable which you are instancing this function SDD classifier, and then you are writing CLF.fill X trend, Y trend. What we are doing? We got these 3 lines to just try to guess. We are choosing first of all an algorithm. Any algorithm ta import SDD classifier, it could have been something else also. There are a host of algorithms which are available in scikit. You are choosing one of them. Next, এই অ্যালগরিদমটা আমি ইনস্টান্সিং, এটা হচ্ছে যারা জাভা সবাই জানো বলে হাত তুলেছিলে তারা নিশ্চয়ই they should be able to understand what is instancing mean. So basically this is a class which I am instancing is CLF equal to this class. So CLF now becomes a actual instance of a class, general class, and then CLF dot fit. So I'm now fitting the data into that model. Full stop. So far we have only done this. Fit, extend and y-train. Extend ta konta? That part. ওই দুটো feature wala. Y ta konta? Na target variable. So we have only fit this. Now this classifier, a bracket, I have not given any parameters. So actually in reality there are a lot of parameters inside each of the algorithm, but if you do not give any, default values will be taken. So we are using default values for the time being. আমরা দেখব পরে how can we change also one or two default values. So যদি আমি এই ব্র্যাকেটে কিছু না দিই মানে I am using whatever internally default values are there. The fit function is probably the most important one. It receives the training data and builds the classifier. Every supervised learning method implements this function. Kono ekta classifier, you instance it and then write dot fit the data. So internally it calculates everything, fits the data, and it waits for your next command, my next instruction. So if I print now CLF dot coefficient, the coefficient is the object. First row of the matrices has the coefficient of linear boundary and intercept attribute, the point of intersection of the line with the y-axis. So if I print the coefficient, I will get this, and the intercept as this. So these are all mathematical things. I am not interested in this. Let's see how we can go forward. Print coefficient বুঝলাম, intercept বুঝলাম, কিন্তু আমার হয়েছে কি হয়নি বুঝবো কি করে? How do I understand that? Let's see. Let's go forward. Indeed, in real place, these three values we can draw a line represented by the following equation. I mean, a 17 or a 28 or 15. Sorry, 17, 28 or 15. এইটা দিয়ে আমরা বেসিক্যালি একটা ইকুয়েশন তৈরি করতে পারি এরকম. So this will represent basically the equation which separates that tape. কিন্তু আমার এটা দরকার নেই, মানে we will not. I'm just explanation এর জন্য এখানে লেখা আছে. So our prediction algorithm will simply check this and predict the corresponding class or any new flower. কেন তিনটে রো আছে সেটা বুঝিয়েছে. এখানে দেখিয়েছে যে এরকম আমি তিন রকম ভাবে সেপাল লেন্থ এর বৃত্তের উপর এ করতে পারি. এই ফার্স্টটা হচ্ছে যেটা আমরা এতক্ষণ ডিসকাস করছিলাম, this one. There are other cases also where for each of the two, মানে 0, 1 and 2, I can do the same sort of things and try to draw the graph. Okay, and it says the first plot shows the model built for our original binary problem. It looks like the line separates quite well the IV status from the rest. For the other two tasks, there are several points that lie on the wrong side. I mean, each tutor model is not right. For us, this will be the one where we can try to use the new value. So now to end of the story, if we have a new flower with a sepal width of 4.7 and a sepal length of 3.1, how to predict the class? So what we do is print CLF.predict scalar transform this new value and the output comes 0. তার মানে 0 মানে এটা সেটোসা. I can change these values 4.7 and 3.1 to something else and then try to predict the output will be coming different. So this is how classification in ML using scikit is done. Steps are মানে এখানে অনেক লেখা ছিল বলে হয়তো sometimes it confused you, but the main points are this. I'm just trying to it's a complete program तो मैंने आपसे क्या किया just hold that. মানে main part I'm just I wanted to repeat what you have to physically do. This is the first part. Load the data. Any load now. This is data set is given, so that's why I am loading. If this is not from the data set, which we will show tomorrow, that if there is an external file, how to load the data, that we will see. So loading the data and trying to get the x and y value from it is first part, which is loading data, breaking it into x and y. This is one part of the job. Second part is where we are dividing the data into a train test split. So this is what it does. It only divides it into test and train data, and then we scale the data if the variation of the data is too much. So then we use this scalar function. Then the next part is very simple. Forget about this part. This plotting may not be required, but this part is important. From this you import a particular classifier or an algorithm, instantiate it, fit the data, and then you use to print either the coefficient or intercept, and then predict it by writing like this, clf.predict. মানে আমি ওটার পরে straight away clf.predict with a new value দিতে পারতাম. That could have been it. Now just to go a little forward, মানে এটা যে আমরা ঠিক হলো কিনা, how do I probably you have noticed that we are predicting a class from the possible 3 classes. So something is missing. You are right. A prediction procedure combines the result of the 3 primary classifiers and select the class which is more confident. So in this case, we select the boundary lines with distance. We get that here into decision function, scalar function. Output is this. Now decision function is another function which gives you this result. Means that we want to be little formal. The performance of the classifier is a measure of its effectiveness. How do I do this? I use from scikit-learn import matrix y train predict is x train. That is a training matrix accuracy of y train and predict. What is y train? Y train is already there in the training data. So now I am comparing the accuracy between through my model y train and y train predicted. Y train predicted is this one. তার মানে এই ট্রেনিং ডেটাটা নিয়ে যে প্রেডিকশনটা করলাম সেইটার সঙ্গে y train মিললো কি মিললো না. Now this prediction accuracy output is coming to say 82%. So that means our classifier is 82% correct, not the remaining 18. Have you understood? So ফিট করলাম, হ্যাঁ এইখানে ফিট করেছি, রাইট, এইখানে আমি ফিট করেছি এইটার পরে আমি তো করলাম, করার পরে আমি যেটা মানে ইউ ক্যান থিঙ্ক অফ লাইক দিস যে আমি এইটা ইম্পোর্ট ম্যাট্রিক্স y train predict equal to predict x train. x trainটা হচ্ছে কোনটা না ট্রেনিং ডেটাটা শুধু x এ, সেইটা দিয়ে প্রেডিক্ট করলাম। তো আমি বুঝিয়ে দিচ্ছি এটা কি শুনতে, আমার মডেলটা এই ডেটাটা নিয়ে আমি একটা প্রেডিক্ট করলাম, আরেকটা এই ডেটা তো আছে অলরেডি, সেইটার দুটোর অ্যাকুরেসি, সেটা যদি আমি অ্যাকুরেসি বেশি হয় মানে আইডিয়ালি এটা 1 হওয়া উচিত। ট্রেনিং ডেটা, ট্রু 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 ট্রু, করার পরে আমি মানে জানো ট্রেনিং ডেটাটাকে দিয়ে একটা আউটপুট পেলাম আর একটা আউটপুট আমার আছে। সো বোথ দিস আউটপুট আই এম কম্পেয়ারিং and trying to find the accuracy. Now accuracy ideally should have come 1. but it is 82. So that means my model is not yet accurate. The most important thing you should note that measuring accuracy on the training set is really a bad idea. You have built your model using these data, so it is possible that your model adjusts well to them but perform poorly in future unseen data. So this phenomena is called overfitting. If I train the data and predict with the same, it's a wrong thing. And that is the reason why we have split the train and the test. Test I have not used the test data yet. So we should have. What we are now doing, a y prediction, just look at this, the difference. A y prediction that with trained data, which is wrong. Whereas this one is with the X test. Test one is a separate data set. Now a y prediction I am now accuracy meaning between y test and y predict. Y test means a part of data with this result. And now it comes, the result is even bad, 0.68. So that is 68. So my model is not at all accurate enough for a realistic way. How many are still with me? So we have obtained an accuracy of 68. Usually accuracy of testing set is lower than the accuracy of the training set. Obviously, our goal will always be to produce models that avoid overfitting, and accuracy in the test set is a good performance measure when the number of instances of each class is similar. But if you have skewed a distribution, say 90% instance belong to one, a classifier will always predict majority in the external performance. True. With scikit, there are several evaluation functions. We will show three popular ones: precision, recall, and F1 score. They assume a binary classification problems in two classes. Precision, recall, or F1 at definition. And we can use this in practice. Print matrix.classification report. Y test, Y pred, target name is this, the output is this. So precision, recall, F1 and support. This table shows we have completed this the same way. The classifier obtained 100% precision and recall in Setosa class. This means that for precision, 100% of instances that are classified as Setosa are really Setosa and recall. But on the other hand, versicolor and results are not good. Because 43 or 65. So যদি unknown জিনিসটা ভার্সিকালার হয় বা unknown জিনিসটা ভার্টিনিকা হয় তাহলে 65% বা 43% দিয়ে এই মডেল অনুযায়ী আমি কারেক্ট পাবো। So এটা really, so also for we have a recall of this, so only 25.7% are correct. So now we can see that our method is very good at predicting only Setosa while it suffers when it has to separate the other two classes. The support value shows how many instances of each class we had in the testing set. The testing set kota chilo seta o dekhache testing set. So this is another useful metric called confusion matrix. Eta amra pore ekটু discuss korbo, kintu ei obdi I just want to give a break for 2 minutes, 3 minutes. I don't know how many of you are still there, but we'll just use some more time on a similar problem to find out how to use algorithm in a scikit-learn. The way we are learning, the way to use it are same for every one of the algorithm. So that means we have to split the data, but we have to first of all take the data, maybe clean some of them, split the data, train the data, that means dot fit, instantaneous, and then you try to predict. And then try to find out the accuracy and confusion matrix. It is something else we need to play around with. Now play around with first of all, there can be two ways. One, the default parameters which are given, we can fix up a little bit of this and that on that to get a better result. One. Two is this, perhaps the SGDM, that classifier itself is wrong chosen. So we can choose another classifier to see if the result coming is better or not. So we change the classifier as well. We take a 3-4 minute break and we'll finish the session by 5. At least today.